Let's get started, guys. Let me just share, turn on the live chat, share the stream. Day 30. Okay. Let's go. So, I trained the model during the night on basically 9 languages for non-HBS and 3 languages for HBS. And there seems to be some errors are going on. We have 89% accuracy and recall only. So I'm curious to see what happens on which of the data sets are we missing. Okay, so I think what we need to do is, instead of adding all the lines like this, I think instead of merging them together and testing, we just need to split. So let's do that. Let's go to the Flores. If the file name ends with target language, so here are the target language. Aha. Okay, it's just Russian. That's why I got this bad score. Let's try and do all of the languages instead. Let's just add all of the languages. Target languages. If you're not in the target language, then we just dismiss it. Okay. Let's do something like this. Turkish, German, Croatian, Bosnian, Serbian. Let's start with HBS and then add the other languages. So let's go back up here, add all of these languages. Plus English. But for English, we have a special flag. So it's going to be processed once. Okay. Let's restart. I'll just have to set this to false and train model to false. And we just want to do the evaluation. And then, as I said, I would love to, instead of extending, I would maybe love to append or create this a dictionary. So let's make it so that this is a dictionary. And then we want to, instead of extending, let's grab the file name, split on the dot, grab the last value, that's going to be the key, and then just equal lines. Okay. So now we can temporarily go and do the following thing. For language direction, lines in all lines items. let's dynamically build these files. Flores, language direction, save, and then test and print results. Okay, let's do this. Hit run. Save, test, print the results. Fun, okay. Why did that happen? Oh, because I joined the all lines instead of lines. Save to the file. Okay, let's rerun. There was a bug there. Okay, all of these are perfect. Same here. Same here. Same. Same. Unhashable type slice. What? Okay. We have to download first all of these files as well. I didn't download many of these languages, so we don't have them in the eval. So I have to go to download Perl Corpora, get here and add all of these new languages. 1, 2, 3, 4, 5, 6, 7, 8. Plus Serbian Cyrillic. Let's start with the HBS languages. Bosnian as well. And Croatian. And then that's going to be language codes. And then we need to modify them. So for language code and language codes, we create English Latin to this language code. Like this. And then we just pass in this here. Okay, let's kick it off. This will fail because I didn't delete the previous one. Let me just quickly delete all of these and rerun. No such file. Which one? Russian, Latin. That's a mistake there. It's Cyrillic. So that means we have the same error in the train LID file as well. Cyrillic, Latin, Latin, German, Turkish, Russian, French, Polish, Arabic, Spanish. Okay. kick it off again. Nice. Go back to train LID. We should have 9 plus 3, 12 languages in the dictionary. But we have 11. Why is that? Bosnian, Serbian, Croatian? Wait a sec. German, Turkish, Russian, Greek, French, Polish, Arabic, and Spanish. That's like 8. Plus 9 for the English. So which one did fail? Let's go to eval. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 here as well. So then why do we have only 11 here? Is English missing maybe? No, English is not missing. Aha, Russian. That was the bug I had. Russian shouldn't be Latin. Russian should be Cyrillic. Okay, repeat. Stop this and repeat. Exactly. Okay. That was the last modification. Just put the breakpoint here and let's see the results. Okay, so perfect for Serbian, Bosnian, all these are perfect, but Polish sometimes gets confused for HBS, and Russian as well gets confused for HBS even more often than Polish. Given these results, we need to include more Russian to the model. And that's going to be the last modification I make. So we need more Russian because it's super similar, I guess, to Serbian, Cyrillic. And the model is getting confused. Let me just share this with the people in the server. Results after adding 9 links to non-HBS category. Almost perfect, except for the Russian, which is similar when looking at n-grams to Serbian Cyrillic. I'll upsample the amount of Russian, retrain, and retest again. And that's, I think, enough for this first iteration. Okay. Stop. Set generate data to true. Train model to true. What I need to do is get a bit more Russian sentences. I made the mistake of not dumping the intermediate sentences. I just have the final file, so maybe we can just add to that file without modifying anything, just add a bit more Russian. That's gonna be the easiest thing to do so we don't have to wait again. Okay, so let me see here quickly. HBS, train, pickle, non-HBS. Let's collect a bit more Russian. And then let's refactor. Okay, so let me just put some notes, some to-dos. So upsample Russian, commit the changes, and test this is the set of to-dos for today, actually for this stream. Next up. Okay. So the easiest thing to handle Russian is I'm going to do the following modification. I'm going to create a new function. Copy this one, just quickly modify it. Upsample Russian. Just leave Russian here. Set the target at 3 million as well. And then just get some Russian data. We will open this, but we will not skip this part. Delete everything that's not Russian. Go through the datasets. Open and add here. Okay, this is going to collect us some Russian, and then we're going to subsample the Russian. And then we're going to dump it to, well, actually we don't want to store it. Actually, we don't want this either. We just want some Russian. We don't need this. We just need the filtering. We do need this. And we do need this as well. So, okay. We've got Russian data. This is going to be Russian. And then we'll load the previous lines. And then we merge them together. And then we filter again. Or better yet, why not add the lines? Let me think for a second here, guys. If I just add Russian to the existing lines, we'll have some duplicates. So I want to filter out this again. How do we build the data? Okay, data should be... Let's see what we do here. Source language. There is no way for us to... Am I doing fuzzy filtering or what? Yeah, we're doing exact filtering. So because it's exact filtering, we actually don't care as much. So filter. Post-process and add lines. Okay, let's just remove the labels temporarily. If I remove the labels and I put all of them in the same bucket, and then I call filter, and then if we filter this, we should be good. And then we can just save this. Combine it with generate HBS, shuffle, and write. Let's run this. This is the quickest way to get some Russian data without having to rerun everything. So get some Russian data. should be fairly quick to do this. Russian may have a bit more text, like 40 million or something. Okay, we are done. Let me see the numbers. 44 million, as I said. So now let's sample to 6 million. Randomly sample 6 million. Next up, we filter this data. So we start with 6 million here, 44, then 6, then filtering. I'm sure we will not filter more than 50%, so that leaves us with at least 3 million. Then we post-process those lines here. We can maybe quickly dump the pickle here just in case we lose this progress, so I can resume. Okay, almost there. Filters TMP. What's the TMP file? While this is running, let me just do a couple of things. Filtering TMP. This is in fairsec. Let's go to Stopes. Aha. Okay, that's it. That we will need this while we are debugging. LID has changed. And configs. What did I change there? Okay, we'll commit all of this. And configs as well. Processing the data. It's first going to subsample to precisely 3 million and then processed. And we add a label as well. Followed by a space. Okay, while we are waiting for this, let me see what changes I've got here. binzip, these are just directories. YAML files, don't care about these. So train LID is the only thing that I've changed. Line code mappings as well, and download stuff. Dataset utils, everything under data. Let's check these files. I think I just added a couple of new, two-letter codes. That's all. Train LID is a completely new file. Everything is new there. Download and dataset utils. Let's quickly analyze this. Length filter. Okay, we can save all of this. As well as this. I think I just added new languages here, that's the only change. And TQDM. Okay, this can all be submitted. And here we don't want to commit this. This is just commenting out, and okay. Fair enough. We don't want to commit this, and we want to commit this after some refactoring has taken place. Okay, this is actually all good. This is good, this is good, this is good, this is good. Maybe this can be a bit modified. And maybe we need to update the normalize with the URL logic. Okay. I'm gonna copy this. Go back to Stopes. Go here. update this with, whoops, normalize. Maybe we can add a minimum length that's going to be considered, otherwise too low of precision. Minimum length. Exactly. Okay. Nothing else needs to be changed. Cool. Almost there with Russian. Let's wait for this to finish. As I said, I just want to temporarily here this is just a throwaway function, obviously. 20 more percent to go. See how many lines we've got. $3 million exactly. Now let's dump this. Russian data clean. Like this. Okay, we saved it. We then load the lines. And now we need to merge them. Before we can filter them again. Grab the lines. Build the filters. And go through the lines one by one. Okay, I already noticed a problem. Maybe the line filter will be filtering. Let's just run this, but I'm afraid we'll be losing some data due to this prefix. So we added the label non-HBS or HBS because we have a length filter. So it's not fair to count that in. Effectively, we'll end up having smaller threshold than 1050. Okay, maybe that's not that big of a difference. Let's see how much we filter out. So we started with, let's see how many lines, 3 million plus 9 point something. Okay, let's continue. I hope that most data will be filtered out by the exact deduplication filter. I wish I could parallelize this somehow. It's too slow. The length filter can be parallelized, but exact dedupe cannot. Without adding some synchronization primitives. Okay, I don't want to go there. Let's see whether we get better results by adding more Russian. And hopefully I didn't make any error. So we had the previous 12 languages packed into a file. Actually 9 languages for non-HBS. Among them, some were Russian sentences. And now I've added 3 million new sentences. Which in retrospect might have been too much. Because I already had 1 million. And they were randomly sampled, so there is a big chance that this exact deduplication will not catch that many sentences actually. Let me see where we stand at the moment. Only 180,000 and a couple of them because of length as well. Okay, that's not great given that we are 70% in. I expected more like million sentences of Russian to be filtered out. So we'll end up having the most sentences in Russian in the whole dataset, which is maybe not a bad thing because Serbian Cyrillic and Russian Cyrillic are similar and easily confusable. I should have added Macedonian as well. Let's see what we get. So 300,000 deduplicated here and 1,000 lost due to length. That's fine. We don't care about 1,000 lines. Let's exit here and retrieve back the lines. So 12 million lines here and 10 million lines here. We combine them, we shuffle them, and before we dump them, I want to change the name of the previous data set. Before Russian upsampling. Curious to see how better we become. So we were at 79 previously. If we push the needle at least a bit, but maybe like 85%, that would be super cool. And finally, kick off the model training. 50% there. Read this yesterday. Has anybody made something similar, like a small device that basically helps you translate real time? Real-time language interpreter. Second, guys. He's saying Star Trek. Good start would be to stop watching Star Trek. Optimism versus pessimism. Realism. Concretely, how does it work? Awesome. The model is ready. Okay, this looks better. This looks better. Let's get going. Let me just commit the changes first. Or actually, let's test this new model. I don't think I have to change the path because it's the same HBS LID model bin. You can stop this. Go to Stopes. Delete all of this, LID. Let's run 3 languages, all of the data sets. So let me just think about the threshold. We currently have 0.9. Let's say if you're 0.85. So if your confidence is below 85%, in that case or even 80. Let's go like 0.8. In that case, we filter out. So if we're an HBS language, we are less than 80% sure that it's HBS, we flag that sentence. Go to filter. Delete the output folder, kick off the run. wait for the 3 files to pop up here. And then we can start analyzing real time the types of sentences that we are filtering out. Bosnian. Snap. What did I do now here? Normalize takes 1. Forgot to add self. Kick it off. So again, what we are doing is we are going through the data for English Bosnian, English Croatian, English Serbian, and on both sides of the equation we are looking for sentences that were flagged by the LID system as not being in the expected language. That's what this is doing. Okay. Quick break while this is running, and then we can continue. Let's analyze the data. Let's go with Bosnian first. It's gonna be hard, that's why I have this temporary file. Let's run this. Okay. Okay, these are all good catches. This is a combination of Greek and something, German and something. This is probably French. This is Serbian probably. Greek. And this is just bad translation. Messed up sentence. Let's see the target. This is supposed to be Croatian. Mostly it's not. A lot of English. German. I guess Polish. This was actually Croatian, but false positive. Greek. Polish, Russian. A lot of English. We caught a lot of shitty text. This is good. Let's go with Serbian. Run. a lot of low quality combination of Serbian Cyrillic with whatever. A lot of duplicates here. Should be good to first filter out the duplicates before we analyze this. A lot of English. Aha, well, this is supposed to be English, but it's combined. Let me see, why is this? This is all flagged at around 70%. This is 17 for some reason. Do you feel your life is in the right place? Which is perfectly good translation. How can we even make sure that this will be better than the NLLB system is? We don't have any way to evaluate. Maybe, just maybe on the NLLB seed, we can check the results because that's curated. Although these are all super low resource languages, we won't be performing well on this. Yeah, that's out of the question as well. Gonna be super slow because the LID filter is slowing things down. First, it's huge. Secondly, the processing is kind of slow as well. There's a ton of perfectly valid translations being filtered out because we need to lower down the threshold, I think. We need to put like 50%, 0.5. Let's rerun this. I'm gonna stop this run. Let's split these debug files into source and target, and let's analyze them independently. Okay, this one is mostly Serbian, and it's 0.49. So we need to put 0.5 as a threshold, I think, for source. Sometimes it's completely is bad, plain bad. 0.13, this is a perfectly valid English sentence. Let's see the target side. Okay, let's modify this file so that we don't remove the initial part of the sentence. At least if the line starts with target. Okay, so pick up line until 1, 2, 3. Let's say first 10 lines. Will that work? 3, 4, 5, 6, 7, 8. 6, 7, 8, 9. Okay, rerun. Looking better. Mostly English. Yeah, we'll never be able to fix this because this is a perfectly valid sentence and it's like 0.06. Let's create a histogram of these scores quickly, just to understand where the peak is at. So target zero, 1, 2 from 3. Zero, 1, 2, 3, 4. So 4, 5, 6, and 7. 4, 5, 6, and 7. Let's say target. If it starts with a target, convert this to float. Print what we want to do, histogram of scores. Count on y-axis, score on x. Let's see what we get here. Okay, indeed, I think we should just put 0.5 here. Let's see what we get for source. Okay, for source it's a bit more difficult. There is a ton of these which are the most of the most data lies from 0.5 to 0.8 actually. That's the issue with source. This is again Bosnian. This is a lot of valid English text. Let's further split the source line. Source lines, low score. If this is smaller than 0.5, and then high score. High score. And now let's dump these. Source low. Source high score. High score. Low and high scores. Run. This is the low score. Makes me think we shouldn't even be filtering based on the source side. This is always mostly English. Guys, I think we should literally just be using target as opposed to English. English is usually much better than the other side. So let's see high score. Even more so English. Yeah. And let's repeat this for target. Exactly. Okay. Rerun. Low score. English. There's still gonna be some bad false positives. High score. Let's try Croatian. Low score for Croatian target. French, German, Greek, various formulas, Polish. Okay, this is actually decently good set of sentences that we don't want. Let's see this, the high scores. And Serbian. Some Russian. Okay. This is general low quality stuff. I definitely think we should only be filtering or source needs to be filtered out only if it's very low score. Like only if it's like, let me see. But even if it's low score, I mostly see English here. Let's go like very low score for this side. So for source, let's like go 0.1 at least. And rerun this. Okay. Okay, this is now very low score. This is still mostly English. Let's go even lower. Let's go 0.05 with equal sign. And the last, if it's equal to 0. Okay, this is much better. This is mostly good filter. All of these sentences are not in English, mostly, for the most part. So that's going to make me devise a bit different strategy here with thresholds. We should have like 0.5 for target and 0 for source. Compute the scores, and then if the score exists and this is not excluded language, we filter it out. Okay. I need to set 2 thresholds instead of just 1. So configs. Threshold should be a dictionary. Let's try that. Thresholds, source language, target language. So for, let's say for English, we should put 0. Thresholds. This should work, I think. Put a breakpoint here. Go to filter. Run. Okay, let's see. Thresholds. Nice. This should be 0. And this should be 0.5. Awesome. 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 That's it. That's all we need. Okay. Okay, there's a couple of things I want to do. Submit the code and set up this for the filtering run. This is going to be our final filtering run for the first iteration at least, and then we can iterate. I don't want to spend any more time here. Okay, directions. Looking good. I think we have everything open here. Nothing is commented out. That's good. Same is in mind. Included corpora. We're not using laser. We are using length. That's good. Somewhat arbitrarily, we'll put 0.5 here. If digits to character ratio is too high, we will filter out. If the words with alpha ratio is too low, we will filter out that sentence. Don't use debug. Toxicity. Deduplication. Fuzzy. Okay, so I think all of this is good enough of a setting for now, except let me just think for this one. Fuzzy dedupe 10 and 0.5. I mean, it was good for Pile. It should be good for us as a rule of thumb. Number of workers is the only thing that kind of worries me. Let me just copy paste all of this up until laser. all the way up to laser. Mine corpora. Awesome. This is great. Let's just see this number of workers argument. We need to go and find the HBS LID filter. And then find deduplication. The number of workers, let's just see where it is used. It's used to build a parallel LSH, that's fine. Is it used anywhere else? No, it's not. So what that means in practice is that we'll be maybe have like 30 processes running in parallel when we have 3 directions. So 10 is, I think, 10 is a good choice. I'll just leave it at 10. And let's set debug to false. Let's quickly run through the filters and see whether I have changed the debug to true anywhere. This one doesn't even have debug. Symbols has debug set to true. Let's just remove that. After symbols, LID. After LID, toxicity. After toxicity, exact and fuzzy, deduplication. Debug set to false there. And debug set to debug, it does not exist in the exact deduplication case. Okay, awesome. I'm happy with the setting. Let me now commit all the changes, kick off the run, and end the stream while it is running. I don't want to be streaming while it's running. I want to do something else. Download parallel corpora. What happens if I don't pass any codes? Nothing, we just don't do anything. Okay. Maybe then we can just pass in this and check this in. See what's the difference. The only difference is that we've added different codes. Okay, that's fine. And finally, train LID. I need to backtrack a bit here. Okay. Let's quickly see how this looks like. This is all good. I didn't touch any of this. Okay, I won't spend too much time making this perfect. Add. Train LID. Commit. And let's do the same for scopes. Dedupe LID symbols. Okay, let's just verify those make sense. I don't want to submit temporary, but I want to check under filtering. All of the changes there should probably be submitted. Symbols, probably a minor change, just a flag being changed. LID, same thing here. I just added self here. And then modified this a bit. Dedupe. Same here. kind of big description, but oops, okay. I'll have to do this a bit later. Final thing, kick off the run, and just step through quickly just to catch any potential issues. See if there is any. Hello. How complete do you think this project is in percentage? Oh my god, there is no such a thing. It can be as open-ended as we want, but like for the first couple of milestones, I'm close to training the 650 million model. I would say maybe, well, I think I've built a ton of understanding of the code base. Now it's mostly about having the compute, honestly. Like I already know everything, how everything works perfectly. So, having said that, maybe around 30%, maybe, I don't know. For the first milestones, which you can check on the roadmap on my GitHub under the project. Okay, go to filter. Kick off the run. Let me just think for a second. For Serbian, we might have less data. Just because we have Cyrillic and Latin, and I split those up. Okay. Hit run. I want to put a breakpoint in each and every one of these symbols. LID. Length. Laser we are not using. Dedupe. Fuzzy. I think that's it. So length, symbols, LID, toxicity, dedupe, fuzzy. Okay. We might have missed the length, so I'm going to stop this one now. Okay, rerun. One more thing. Output directory is going to be filter out HBS. And let's make sure that one is clear. Filter out HBS. Clear. Go to filter. Hit run. And then go step by step. How do we end up there before hitting the breakpoint? Okay, I guess we'll see soon enough. Why didn't we hit this breakpoint? I don't know. That's weird. Okay. LID. Source should be 0, target should be 0.5. Exactly. Load the model. Let me see what's the memory consumption. 30 gigabytes. Okay. And then toxicity filter. We did improve the toxicity lists as well. It's crazy how much work we've done. It's crazy. Like, I've added fuzzy. It did not exist. I've improved all of the lists for toxicity. We've trained the LID model. We've added the symbols which did not exist. A ton of cool work has been done for filtering here. And then dedupe. Okay. That's cool. So now we'll have, again, two stages. First one is the before fuzzy and then the fuzzy. In the before fuzzy, we'll be printing out these intermediate files. And then in the fuzzy, we'll be reading from them and printing to the gzip file. I'm going to remove all the breakpoints here. We will also be logging and tracking all of this in weights and biases. So let me quickly open up weights and biases. Okay, there is a ton of jobs here. Visualize none. Can we delete this somehow? I think we can. I did this the last time. Let me see. One thing that sucks with weights and biases is it's not really intuitive how to delete stuff. Okay. Let's not delete the running ones, but let's delete everything else. Let's display all 100. And just not include these. And then delete. Awesome. Now this is a clean situation. Let's see where we stopped. Hit run. Let's wait until we hit the filters. Okay, and we are here. So filtering. Find the maximum length. If you're smaller than the min length, we filter. If you're bigger than the max length, we filter. And repeat the same for, and then the ratio. And then this, which will never hit. Okay, hit run. We're now, again, length filter. We can just remove this. Symbols filter. We go through the line, count the hashtag number. If it's bigger than the threshold, we filter out. Same here. Get the digit to character ratio. If it's too high, we filter out. And finally here, get ratio of words with alpha. If it's too small, we filter out. Repeat the same process here. Remove breakpoint, run. HBS filter. I guess the trickiest one is going to be just a fuzzy. The fuzzy deduplication. If you're smaller than this length, then we just ignore you. Otherwise, predict. And first normalize. And so we end up with what? Let me see the type of sentence we end up with. And then we grab the probabilities and we ask, hey, what's the non-HBS for source? Because source should be non-HBS. Source is English, always. Okay? And then we predict the target and we say what's the HBS, because target should always be HBS. And then if source threshold exists, aha. Okay, I already noticed a problem. That was a bug. If it's bigger or equal than 0. In that case, we enter. And if it's smaller than the threshold or equal than the threshold, then we filter out. Let's see, same here. We filter out. Okay. Let's continue. Toxicity filter. I think this is the last one. Okay, there is the exact deduplication, which we never changed to the best of my recall. If it's not none, which it's not, grab the toxicity count. If it's too high, then we filter out. Here, the same thing. If it's too high, we filter out. And if the absolute difference is bigger than 1, we filter out as well. And finally, exact deduplication. Normalize, normalize. pairs. We construct the sentence. We create a hash, and if it's seen already, we remove it. Basically, that's it. And that's it, guys. So I have to restart just because we found a bug in one of the filters, and that was the with 0, the LID filter. Disable all breakpoints until we get to fuzzy. Once we get there, I will want to have a breakpoint here and here. Okay. Again, we can delete this. Kick off the run. Let's wait until we get some results here. Are we running? We are. Awesome, guys. That's it. Kick off the run. Let me just put an update here. let me just put some updates here. So symbols LID is trained, toxicity has been improved. And finally added fuzzy. Let me just approve Rafael's pull request. Aha. He actually didn't download it completely. Let's see how this is working. Making progress. Guys, with this, I think I'm gonna end this stream a bit earlier. I'm gonna go take a walk outside, chill a bit while this is running. And I'm gonna commit the changes. We're waiting for the filtering job to finish. I might take some time to reach out to some people for potentially sharing with me some private data for Serbian. So I think I'm gonna do that actually after the stream. Okay guys, this was super cool, ton of good work. We trained the new model, we upsampled the Russian, seems it's working properly, definitely better on Flores. I unfortunately don't have any better evaluation dataset. If you're aware of something where we could have a certainty that monolingual corpus is in precisely the language that is stated, in that case we can test on that one and compare how OpenLID compares with our fasttext model versus the NLLB fasttext model. Okay guys, catch you later. Have a nice day.